Hello everyone, how's it going today? And today I'm gonna show you about how to use the C++ concurrency and horizons. The first I just to define it clearly about the concurrency and the parallel some programming. This is the two independent topic, The concurrency we can is in the one CPU space time we just use in the hardware concurrency and multi-question we just to use in the same hardware space. We use the task switching for multi-threading units and we use it in the same data space, and the parallels we creating different thread in the time equal expensive in the terms of both time and memory overhead for the program, the cost of which, and when dealing with a short duration, the same looks function, it can use sometimes work or the like this, and it can test you the parallel execution policy annotation in a way that mocking a certain function as candidate for the currency without being free as basically as more basic diagnosis to mark they can be encoded into the function. The first in the parallel we can check to the compiler that function become basic concurrently with the other function. However, the compiler may overrule this if the results are related, the other sequence rule, meaning that the function must be calculated individually, and parallel function can significantly speed up the operation because they automatically use more of the computer CPU resource. However, it's best safe for the function that have little interaction with the other function. What we need is other function outcome not attempt to the same data. It's because while they are work on the concurrently, there's no way to know that we will come the first of the mini rules in unpredictable can synchronization such as the multitask or the condition variable are used. You know, imagine having the two variable a and b create a function and so have if the function for important same variable would is want to use the sequential execution, but the multi-rate we use the same data. This is a different the two independent topic, just to focus on that. So and in this tutorial I will go through the how to create, how to use the track, how to share the data, and how to use the new text for log data, how to use the logs, how to use the thread save visualization, data, and direct local data and the condition variable and the task. So is the task, you know, the multi-thread we can in a C++, let's consider a lot of threads and synchronization remain empty for the shader, the right local data, and the task. If you don't know about the task, you can build the OTOS real-time operating system in the previous videos in my YouTube channel. But in this video, I just on the top add like direct represent the independent unit upload and execution. This scalable unit which start immediately receive a work back on the con unit. The con unit can be an function and the object unload the function. The creator of the responsible for its lifetime is scalable units for the neutral and of with and of the conical. Either the creator waiting to create a 3T even join the tab and determine and create a track and the strategy. Awesome. You have to coordinate and set to the share variable if more than one track you see the center and the variable immutable. This means it's not constant, and you just reading and writing a share variable at the same time is a data race, and therefore the undefined behavior coordinating is set to the share variable each just with a mutex and locked in C and C++, and the mutex either it means the mutable exclusion guarantee that only track can set the share variable at any given time the multiploss and unlock the created processor. The share variable belong to the C++ can apply different mutex can lock recursively, tentatively, without and the sum with the time constant. Even mutexes can share lock at the same time. Lock we should encapsulate the mutex in a lock to realize mutex ultimately. A lock implement the LE2 item by multiply time with an LC. Let's had a lockout for the single case and unit lock and a shell lock for the advanced use case. Just at least lock and unlock the mutex. Respectively, and we say initialization of data. If a shader is read only, it's sufficiently to initialize in the precisely way. It's a right way to adjust it, including in using constant expression, the state variable of the block scope using function con ones in combination with a flag in the one flag, and the group locator is mean you declaring a variable as the group locator so that the group can't hold up either or there are no share variable. The lifetime of the flag local time is down to the lifetime of the flag, and the conditional variable, the conditional variable enable thread to be seen drive out a message, and one for add to the send while another on add as receive at of the message, whether receive log waited for a message from the sender type because use the case of call condition variable of produce and consumer workflow, and the condition variable can be either the send or the receive of a message. Using condition variable currently is quite challenging, so therefore the tasks are for the easier solution, and the minimum the unit in concurrently and multi-threading programming your tasks. Tasks have a lot of common which require you explicitly create your task in the chart you start. You see, plus the runtime will automatically handle. In a simple case of a synchronization in the light time of the task, a likely data channel between two communication and void, and the enable basic communication between the back and promise at the endpoint load data into the data channel. And the future, the endpoint pick up the value. The data can be a value, an accession, or simply notification. Of course, in relation to the synchronization, you see Blockers has the glass template, the promise and the future in a standard library that give you more control over the task. So, in the first example, I'll call um, a symbol example for you about how to create a task and how to join and how to detect a task in this tutorial. Similar to about the real-time operating system. The first, I just to create a task. So in this step, I will input two parameters. The first parameter is the integers, and the second is the string. So we just to create So in the first parameter, I will convert to the string and add dot and add to the string. And after that, I will output the message. So in the main thread, I just say the main thread because the main function is a thread. I will create a string. So in this string, I will input many string. Okay, after that we create a vector thread. So now I'm boost back the track to the best using the boost back method. Now we just to look for all the string. So now I'm create one track. I call the function name and I input two parameters I and string. I is the index, So after that I use the for look for bring all of them. In this case I use O2 key. And I will look for all the track. And now I'm trying task. So now we'll combine. Okay, as you can see, we have a 4 track, and this is the priority of the one track, So now I will detect it. So this is the result of this assembly. The first I create the track and the boost back on the track to the better. After that I create a for loop for look all of feather element, and I will use the detect and the try function. The try function is mean we created one track from the main thread, and after do this task we will move after to the main thread, and the detect will create a thread, and this thread will run independently with the main thread. This is different from to the top, and in the next video I will show you how to use the thread editor, the multitask, and the log the tracing initialization of the data, thread local data, and the condition variable in the task. Thank you for watching this video.